Hello, Axel Werkhausen speaking from Austria. We do have just members already online compared to the number of registrations. I beg your pardon. May start right now. Waited 5 minutes to pardon were on time. We just now. So today's webinar, short introduction into peak software FEMFAT for finite element method peak and engine soft being for Italy has planned this webinar. I was invited to do a short introduction to where is the software developed, what is the company behind, are the key functions, and how you can use it easily with your products. So first of all, I would like to give a short impression. MAGNA has bought the engineering center Steyr about 20 years ago, 1998. And from that time, we increased our market share and partnerships to all over the world due to the MAGNA head offices in most of the countries. We do have a great representative. We do have capability inside MAGNA for nearly everything in the country. So MAGNA could build a complete car and build the car within factories which are spread all. And our engineering center Steyr is quite famous for software development and testing. Software development and to be at the same place is a good opportunity and has a great benefit for developing software, as we have peak test laboratories and the possibility to compare directly with this made in our structure analysis team. Other testings like a test drive off-road vehicles and trucks and lorries, special purpose vehicles, engine test beds. Also, this is possible information field that helps us for thermomechanical fatigue in engine components. Also, testing facility having the capability airflow to an engine. So everything that has to do with driving comfort can be tested with the test tracks and this chamber, the airflow. And you see here a bird view from our company. We are now located here, this building, and building here is our boutique laboratories. Here is the test bench, it's about here, and the engine test beds, this one is in this big building here is a small production. We do have small production for various customers with low volumes like the VW Caddy, Axis, differential Ferrari. In the production area, this bird view from the ground. We have different abilities here to run Sinus washboard for frame structures in trucks and lorries. We have some acoustic areas where we do pass-by noise measurement and a flooding basin, special purpose. Different tracks are here, very condensed on our location. This is again our office building production to get to this proving ground there is a direct connection here. The Powertrain Engineering, just an I want to express that simulation service and software is mainly in the structure analysis and also with thermal management. The Cooley is quite famous, and again, same as FEMFAT, so the second big software package for energy management. We use FEMFAT, of course, not only in the phase of development, but also consulting team. We do have 28 people doing consulting with the software together other, which, for example, are enabled in T-body dynamics. So Mamba, for example, is a package, or M noise vibration and harshness. There is a lot of ability to combine FEMFAT with our ECS software products for development. So why is FEMFAT, finite element method for fatigue? Why has it developed in 19? There was a situation when we did stress analysis, stated parts and dynamic load parts, and paired with testing peak test bench, we very often found out that maximum stress is not the same location as we have cracks initiated the dynamic. This comes because maximum stress does not always say that there is a number of smaller cycles maybe in other areas that can have a more damaging effect than maximum stress, which just one time occurs. One life cycle is to go for multi-axial fatigue stress analysis together fatigue analysis. And after some validation process, when you get a software running company together, your finite element preprocessor, for example, you have ANSYS, or you do have MSC product with Astran and Patran, or Dina products, or whatever, or Hypermesh. So any kind of finite element preprocessor provides a finite element mesh. This finite element mesh is in FEMFAT together with a result from a finite element solver. Again, one of these. These stresses are static stresses by now. So you have to define somehow load cycles or a load history, measurement data from laboratories or virtual measurements. This is the input to make static stresses somehow dynamic. And the software itself takes the stress tensor from the FE solver and compares the stresses and the equivalent stress to material data. Evaluating from stress tensor element FE node, we evaluate an equivalent stress, and the equivalent stress is compared to, for example, the endurance limit of an SN curve to find out what is safety factor or what is degree of utilization from this load. Result calculated with any means of modules, I come to the module, will create a result from this damage analysis, safety factor analysis, and we can directly export it to your post-processing. So you go back into ANSYS, post-process it by an RST result, any kind of reports, And also you can directly act on our database, the internal tool Visualiser, which is also a post-processing feature. Post-processing tool has a direct contact to our database file. Database file by interface, you can get the output for your processing desired for any kind you already have. The concept in FEMFAT is little similar to the FKM guideline. The FKM guideline is a guideline which was developed in Germany to help engineers figure out about development of components with this guideline to be safe side to take into account, for example, surface treatments or thermomechanical effects or temperature on each material. And we took the same feature and said, well, normally the component suffer from such an effect. The temperature, which is not 20-degree room temperature, higher, this will lower, for example, the physical capability material. So based on the ideal specimen procedure, unnotched, greatly in area, it is polished, so there is no surface roughness. It is tested under room temperature, so this is an ideal work of this material. Starting with this, we detect several influences, we call it influences, into the fatigue life. What is a typical temperature told? This SN curve normally applies stress amplitudes with number of cycles, but many kind of loading do have a mean stress. So pulsating load, for example, does not only have the amplitude, but also mean stress. Mean stress has to be taken into account to lower or even increase the SN curve according to the load situation. Tempering conditions. Statistics can be taken into account. So if the SN curve is generated from testing, number of specimens and the spread of the number of cycles on one level is an indication for statistics. So how good does the material curve already fit my existing? So all of these influences taken into account to create what we call a modified SN curve where everywhere we do have, for example, in here, different temperatures. SN curve for every FE is different compared to the original material SN curve, which is everywhere the same. The modified SN curve in this component can be totally diverse and different to FE. We take into account uniaxial load, basic, which is a can take axial load. We have X, Y, Z loadings acting on the same time. We start with analysis and the comparison cases being unit load cases and run into multi-axiality. Stochastic effects like a PSD, spectral density, be loading a peak analysis. Thermomechanical, other one, temperature at a special level, special temperature, you can last, for example, high cycle, mechanical load, and temperature in different levels. This is according to Professor Glue from the United States for thermomechanical fatigue. Possible analysis targets are the damage, so how long I can stand such a loading, or how many times I can repeat thing brake is initiated. Some others need an endurance safety factor. I have to provide a certain safety factor for every part in my train, for example, or in my railway bogie, only to convince justification to get some certificate, for example. Sometimes I'm interested just in the degree of multi-axiality. So I know there are different eigenmodes acting on my component, and due to the different, like a landing version, to see how multi-axial my part is effectively, or just a static safety factor, so one-time action just taken into account. If my one-time action, this one-time static case. We started with materials mainly with metals, aluminiums, went of course also to newer materials, glass. This we went into plastics, reinforced plastic, fiber in combination with casting simulation, where casting simulation predict orientation and the position of fibers oriented by loading directions. Also with custom rubbers, special treatment on that one, capable software to predict damage and safety factors. A module which is recently in 2015 released, laminated structures, is a complicated just fiber reinforced plastics, and due to the different peak behavior of such laminates, the analysis strategy is totally different to fiber reinforced plastic. Touch it a little. Some of these parts also need to be connected by, for example, weld seam lines, or with spot welds or self-piercing rivets, clinching. So these are spot welds and clinch are taken into account by our connection techniques. Weld of them. Normally, to talk about the modules is one possibility, but to adjust the selected module according to your applications. You do have a problem or application you want to do an analysis for. We support you suggesting right modules, and sometimes maybe also tell you about a simple way to handle your problem where you need maybe only a fewer modules, make it a little easier, like maximum excitation in a connecting rod can be analyzed simply with FEMFAT Basic. And if it goes into the sports division, they do not only run this analysis to maximum cases, ignition and combustion, but they also want to know it every crank angle degree in between to really save, for example, weight on this connecting their best. To start with maybe a simple kind of analysis can increase degree of complexity to help taking other modules into account. multi-axial, for example, it should not only run connecting rod, but bearing and bearing shell, then this degree of multi-axiality is increased because in every degree of crank angle, you do have a different loading. You can take into account pressure distribution for hydrodynamic bearing simulation in the same process to get it more detailed again. And this type is then typically handled with max zero. Okay, so transient analysis, for example, here, case 2 and 15, these are the two maximum create minimum safety extra position. And depend on your the kind of testing and the load, it happens. Test benches that work with frequency accelerations. We do have response spectral, taking the frequencies of my response into account a damage analysis. This is capable with load cycles by now taking also mean stress into account, and since 5.3 we also take weld seam into account. Current work is based on spot welds. One feature to come to combine FEMFAT spectra also future. The thermomechanical fatigue, as mentioned, in the United States has three different damage terms. Mechanical damage, which is easily observed, often equation behind the strain rates between lower and higher temperatures. There is an environmental damage. This environmental damage is due to oxidation. Oxidation increases with the elevated temperature, quite complex formula and behavior that helps you to identify environmental damage here. And another damaging algorithm, creep damage. If I keep parts at temperature, then there is some relaxation typically induces also cracks by several number of cycles. Number of cycle mechanical in a very compared to million of cycles. We talk here by 1,000 or 1,000 cycles, because one cycle is start up the engine, run the engine at several RPM, and cool down the engine again. The garage, for it can last many hours, minutes, being just one cycle. Visualiser, as I told you already, post-processing extra feature with which is called module Visualiser. The Visualiser, of course, is adopted to typical behavior, typical from our consulting team. Because, for example, isn't it possible to show weld seam that I have defined my component directly somewhere in the mesh, so I can check if I have provided a one-sided or two-sided fillet. Is it possible to have here a direct check? Visualization tool is a little capable any post-process, but most of the are also other modules which are not mentioned by the extra slide is, for example, brake, static analysis, FEMFAT to take from your linear perspectives. Can be taken into account. The weld seams, as you have seen, Visualiser in to take these welds into account. Spot welds taken in by spot, and to switch the analysis process from wise calculation into element-wise and die-wise calculation. Together, the difference fatigue analysis, correct initiation process. What is the advantage to use FEMFAT to show you that our company directly just next door do this develop really direct contact engineer do take it to can take finding extracts from into our continuously improve software due to requests from Valentine and of to the from our specialty comes not and help him to cover such an effect. Can also to to get easily started. FEMFAT, we also do training. Distributors offer training in a local language, so to listen to my but you to Dario Italian, and together support contact engines to engine source based on is done. Also, we try to take guidelines into account. For example, with 12 requests came to us guidelines, specialties of such guidelines should be taken into account in FEMFAT. Try to get this as accurate as possible concept. For example, it works fine with FEMFAT guideline, quite comprehensive, just database to check. The certification process, German Visualiser GL certification has also helped us to improve developments. improved our inflow counting method, side effect, process, general. Now our renewable windmill energy driven mechanics analysis do not need to run the evaluation process. When we look at the strategy in development, come to market, and due to the steady development of features, due to an increase in customer base, we show a good performance, not only about the revenues, but also customers. Do have customers together with MAGNA project, but the software customers are quite larger base. Sometimes software is the first to later on to create projects, testing, developing parts, but many times software first comes to such customers. Okay. Your symbol on the left, not please immediate test license to problem. Yeah, our distributors in Europe increasing. Italy helps us to overcome the bar to Ari, far away from Vienna or from St. Valentine. Engines to reach out to you. In other locations like China and Japan, we are MAGNA computers, Korea, this engineering team, quite capable engineering to help computership, same as in and United States. These are local resellers. If you are a multi-continental industry, can ensure that the assistance you observe in Italy is similar as Japan and China. So all of them are educated engineers, and they do not have a direct answer. It's possible for them to ask in our office. We communicate to both of you, to the reseller and to the customer directly. We are now getting more interested to how software can be get as a license type. We offer the direct perpetual license, which is a paid-up model. Can also license. You define months or years to, and it is also possible to get it really pay by use model, license service providing. Maybe you know NZ pay of work center or line credits, and also a partnership with Altair, where license Altair hyperwork unit they come out with Alt Partner Alliance, APA. If you are already Altair user, may start this feature. You can apply Partner Alliance to run these partner. Beside EngineSoft, you can also contact our team. We are here, engineers, and always one person is here, direct support at least. And maybe we can see a conference called the CAE conference in Vicenza. FEMA will be there and to meet Vicenza in autumn this year. If you're interested, like demo, or can directly to the software and do calculation. There is already some tech. It's likely capability to see, just looking into the chat, any request or any comment. I just start over of standard version. FEMFAT itself can be run Windows Linux system. You find with startup project file name. You will not have the benefit of 999 licenses at your company. Just for resellers, have no uncounted license. You do get here a little how many more have a software. Here, graphic user interface, where you see the different which are main decision, channel maximum. Here, channel necessary to import before you can run and get visualized. Element mode imported. Things. Simple structure file with 5,800 nodes, 5,000 elements. Structure has been used for benchmark United States Society of Automotive Engineers, so-called Weld Challenge. They did tests on this physically. They fixed its areas here and applied some load direction to twist beam here, and cracks initiated in weld seam tube to create weld seam between two nodes. side fillet weld, which is shown here. HV seam, which has more penetration to the upper sheet, kind of weld, and can go for any other seam project. Any further weld seam, that's just file. So we are now in the visualizer to save weld seam definition. This could be any other engineer. Visualizer also starts up standalone. And for the fatigue analysis, fatigue analyst starts here and says, well, we have a weld seam definition just made. We open this. There are 17 nodes, 52 elements affected to weld seam definition. I here, for example, just one channel. I do have an OP2 file result. Stress result, and I apply 3. Just a 3 between 0 in each cycle, 1,000 cases. I can define different materials. I can import materials from our database directly projects. I can have specific material by project. File. Visualization of a diagram, the EN, the stress strain curve, or the stress cycle. Every FE node has to have a material, like add additional material to the problem, but we have to activate FEMFAT weld if we want to take weld into account. Database, which can be chosen for the different guidelines, as I told you, standard. Select the guide, a database, and take weld seams into account. For example, we just want to know damage of this number of cycles. We try to analyze. Just a click. Analysis is done. Quite simple model. It's quite fast. We know where the maximum damage arises. Is 2,802. The weld seam node. We also detailed information. The material is the weld seam end position. The crack initiates at the toe, seam root, but at the toe. And shell position, it is bottom side. Top side, but the bottom side. To see this visualizer, See, we here directly out can check to node. Okay, it's right here. All the details analysis like damage, of course, like stress amplitude and the mean stress. I already told you it is a pulsating. So have the critical weld seam line 2882, 2923. Next weld seam line. These attributes can be interpreted by the engineer after training. You have different visualization abilities to see distribution of the stress amplitude, for example, to see the local fatigue limit if you do have several materials, fatigue limit, of course, wider spread, the interesting damage, of course, damage, or the safety factor analysis. You have to switch here if you want to utilization degree or the endurance safety limit, which the analysis procedure target is and procedure to do this analysis. Yeah, if you do other questions, free to answer it either the chat box, the email, show you text slide, can get all address, first name, last name, get an within at least 8 hours, few minutes response. Thank you. I'm questions there are.